Hi everyone. In this video, we're going to be doing Mathematics 9709, Paper 31, Pure Maths 3, May, June 2025. This paper is 1 hour 50 minutes, so we'll try to finish it within this time limit. So without further ado, let's get started. Okay, so for the first question, you have to sketch the graph of this modulus function. So let's do that. So first of all, let's sketch our x and y axis. So this is our y-axis and this is our x-axis. Okay, now let's find our x and y intercepts. So to find the x-intercept, just substitute 2x minus 3 equals to 0 and solve for x. So in this case, x would be equals to 3 over 2, which is somewhere here. And then to find the y-intercept, just substitute x equals to 0. So this would be -3 absolute value, which is just, so this would be somewhere here. This is 3, and this is 3 over 2. Hence, our graph would pass through these points. Okay, let me relabel. Oh no. Okay. All right, let me relabel this. And it would be symmetrical about the line passing through the x-intercept. So it would be like this. So this is our final graph. Let's head on to the next question. Okay, so here we're now gonna have to solve this inequality. Okay, so first of all, let's write down this inequality. So since we have the graph up here, we're going to use the graphical method to solve this inequality. So first of all, let's draw a sketch of the function on the left-hand side to see how many intersection points there would be. Okay, so if you substitute x equals to 0 into here, you find out the x-intercept. Let me write this down the back, would be -1, so somewhere here. And then the y-intercept would be 1/3, so something like this. And since the gradient of this line is 3, because the coefficient of x is 3, this line would be steeper than our modulus curve. So all in all, it should look something like this. So as you can see from a rough sketch, there would be 2 intersection points. And so to solve this inequality, we're gonna have to find these 2 points. Okay, so for the first point, we're just going to equate, let me switch to blue. Okay, we're just going to equate 3x minus 1 to the original curve, which is the one on the right. So the original curve, 2x minus 3. And now we just solve for x. So let's move the 2x to the other side. So that would be x, and move the constants to the other side. So -3 plus 1. So that would be -2. So our first point of intersection would be x equals to -2. Okay, and now to find the second point, we're going to equate 3x minus 1 to minus bracket 2x minus 3. So let's solve this. And first of all, let's open up the brackets and expand this. So this would be 3 minus 2x. And let's move all the x's to the left-hand side. So taking plus 2x on both sides, you would have 5x minus 1 equals to 3. And adding 1 on both sides, we get 5x equals to 4. When hence we would get 4x equals to 4 over 5. Oh wait, sorry. My sketch of the curve was wrong. So since this curve 3x, straight line 3x minus 1 is steeper, it would look something like this, with only 1 point of intersection. Yeah. So the only point of intersection would be on the left-hand side of the modulus curve. So and that part of the modulus function is equal to minus 2x bracket, the minus 2x minus 3 bracket. So this solution is invalid. So this would be the only point that we have to work with. So we've got the confusion. Okay, so since we are interested in the values of x where 3x minus 1 is less than the modulus function, we are going to have to look towards the left of the intersection point. So hence, our answer would be x is less than 4 over 5. So this is our final answer. Let's head on to the next question. Okay, so here we're told that 2 ln p plus ln bracket p minus 1 minus half ln q plus 1 is equals to 3. And we're supposed to find q in terms of p. Okay, so first of all, let's write down the equation that we're given. And now let's try to simplify this using our laws of logarithms. Okay, so for the first term, 2 ln p, we can move the 2 up to here to give us ln p squared. So let's do that. And then let's leave the middle term like it is. And we'll do the same thing for this half. We'll move it over and make it a power of q plus 1. So this would be minus ln q plus 1 to the power of half equals to 3. Okay, and now for the first two terms, we can actually combine them since they're basically logarithms with the same base, which is e, and there's a plus sign. So according to this rule, ln a plus ln b equals to ln ab. We can multiply the log. So we'll have ln p squared times p minus 1. And then let's write down the last logarithm. So q plus 1 to the power of half, we can rewrite that as square root q plus 1 equals to 3. Let's expand the left-hand side. This would be p cubed minus p squared bracketed minus 1 square root q plus 1 equals to 3. And now we have two logarithms of the same base separated by minus sign. So like the previous one, when you have two logarithms separated by minus sign, you can use this logarithm rule and just put a division sign between the a and b. So hence, this would be ln p cubed over minus p squared over square root q plus 1. And that would be equals to 3. Okay, now we can make use of the fact. Okay, now let's take e on both sides. So on the left-hand side, the e's will cancel out. So our final solution is e cubed equals to p cubed minus p squared over square root q plus 1. And as you can see in this question, we're going to have to express q in terms of p. So we have to make q the subject of this equation. Okay, so let's multiply both sides by the square root to get rid of the denominator. So we will have e cubed square root q plus 1 equals to p cubed minus p squared. And to make things simpler, let's factorize the p squared from the right-hand side to get p squared bracket p minus 1. And to get rid of the square root, let's square both sides. So this would be, so we just multiply the exponents. So this would be e to the power of 6 times q plus 1. The square root is gone. And for the right-hand side, we do the same. So this would be p to the power of 2 times 2, that's 4, and p minus 1 squared. Okay, now let's divide both sides by e to the power of 6. So we would have q plus 1 equals to p times 4, p to the power of 4 times p minus 1 squared times e to the power of negative 6, which is the same as 1 over e to the power of 6. And then finally, to just make q the subject, we're going to subtract 1 from both sides. So hence, this is our final answer. Q is equals to p to the power 4 times p minus 1 squared times e to the power of negative 6 minus 1. So this is our final answer. Let's head on to the next question. Okay, so here we're going to have to find the complex number z for which this is real and the modulus of z is square root 17. And we're supposed to give our answers in the form z equals to x plus iy, where x and y are real. Okay, so first of all, we shall let z equals to x plus iy. Okay, so now let's substitute. So we shall evaluate this fraction first. So z plus 5i over z minus 5. Let's substitute x plus iy. So x plus iy plus 5i over x minus 5 plus iy. Okay. Now let's separate the real and imaginary parts. So the numerator would be x plus y plus 5 times I over x minus 5 plus yi. All right. So if you have a complex number like this, we have to multiply the denominator by the conjugate of itself so that the denominator becomes real, and then we can make it into a single complex number. So let's do that. So here we're supposed to multiply both the numerator and the denominator by x minus 5 minus yi over x minus 5 minus yi. So our denominator would be x minus 5 squared minus y squared I squared. And then our numerator would be x plus bracket y plus 5i times x minus 5 minus yi. So let's simplify this. So, okay, let's simplify the numerator first. So let's expand it. So x times x minus 5, that is x squared minus 5x, and x times minus yi, that's minus xyi. And then bracket y plus 5i times x minus 5, that is just x minus 5 times y plus 5 I, and then y plus 5 times I minus yi, that is minus y times minus y plus 5 I square. And now let's simplify the denominator. Oh, okay, wait, actually, let's re-express x squared minus 5x as x times x minus 5. Yeah, so, and then we have over x minus 5 squared plus y squared. Since I squared is equals to negative 1, so negative times negative, you'll get positive 1. Okay. And now we're going to simplify the numerator again. Okay, good. We have 2 pages, so there's enough space. Okay, so let's simplify. So we have x times x minus 5. And then all the way at the left-hand side, we have minus y times y plus 5 times I squared. So as I said before, I squared is just minus 1. So minus 1 times minus 1 is plus 1. So we would write plus y times y plus 5. And then for the imaginary part, let's take out I. So we'll have I times y plus 5, x minus 5 minus xy. X minus 5 squared plus y squared. Okay, now let's split up the fraction. So the real part would be x times x minus 5 plus y times y plus 5 over x minus 5 squared plus y squared. And the imaginary part would be y plus 5 times x minus 5 minus xy over x minus 5 squared plus y squared I. Okay, so let's stop here. So the question says that this complex number that we evaluated is real. So when a complex number is real, it means the imaginary part is equal to 0. So we're going to substitute this whole the coefficient of I with 0. So let's do that. So first of all, we can just multiply both sides by the denominator, and we will just have the numerator. Okay, and now we're going to expand this out. So y times x minus 5, that is xy minus 5y, and 5 times x minus 5, that is plus 5x minus 25, and then minus xy, that's equals to 0. So as you can see, we have xy and minus xy, which will both equal 0, so we can cancel that out. So rearranging this, we would have 5x minus 5y minus 25 equals to 0. And from here, we can add 25 to the other side, to both sides, and we'll have 5x minus 5y equals to 25. And dividing by 5 on both sides, we can have our final equation, which is x minus y equals to 5. So this would be our first equation. Okay, so now let's form our second equation. So for that, we have to use our second piece of information, which states that the modulus of z is square root 17. So to find the modulus of z, you just take the square root of x squared plus y squared. And that is equals to square root 17. Okay, let's rearrange this. Let's make x the subject for the first equation, then we'll have x equals to y plus 5. So this is our first equation. Okay, like getting back to the modulus. So squared x squared plus y squared 17. Removing the square root on both sides, we would get x squared plus y squared equals to 17. So this is our equation 2. And now let's copy down both of our equations in the next page. Okay, so since there's no common like terms that we can subtract from both equations, we're going to have to use the substitution method and solve them simultaneously. So as you can see from the first equation, we can use x equals to y plus 5 to solve the second equation. So we're going to substitute first equation into the second equation. So this would be y plus 5 squared plus y squared equals to 17. And expanding y plus 5 squared, we would get y squared plus 10y plus 5 squared, which is 25, plus y squared equals to 17. move everything towards the left-hand side. So y squared plus y squared, that's 2y squared plus 10y, and 25 minus 17, that is 8, equals to 0. And since all of the coefficients can be divided by 2, we'll divide both sides by 2. And this is our final quadratic equation. Y squared plus 5y plus 4 equals to 0. Okay, so in order to solve this, you can either use the quadratic formula or factorize, which is what I'm going to do. So we have y plus 1 and y plus 4. Now let's equate both of these factors to 0. So for the first one, we get y equals to -1. And for the second one, we get y equals to -4. These are our two answers. Now let's substitute them into the first equation. So we have x equals to -1 plus 5. So that's just 5 minus 1, which is equals to 4. Then for the second one, we have x equals to -4 plus 5. So 5 minus 4 is equals to 1. So hence, z would be equals to x plus iy. So the first answer would be 4 minus 1i. So that's just minus I. And the second answer would be 1 minus 4i. So these are our two answers for z. And if you want to check whether they satisfy these two equations above, feel free to substitute these into your calculator. And if they satisfy the conditions, then you're good to go. So without further ado, let's head on to the next question.
Recording in progress.
Okay, so for this question, we're given the parametric equations of a curve. So we have x equals to e to the power of tangent t, and y equals to 3 times tangent squared t. And here we're supposed to find the equation of the tangent to the curve at the point E, comma 3. And we're supposed to give our answer in the form y equals to mx plus c, where m and c are exact. Okay, so first of all, in order to find the equation of the tangent, at this point, we're supposed to find the gradient at this point. And in order to find the gradient, we have to find dy dx. But we are not given the equation of y in terms of x. We're given in terms of a parameter t. So we're going to have to use this formula according to the chain rule, dy dt divided by dx dt. So first, let's find dy dt. So write down equation of y in terms of t. And now we can find dy dt. So let's take out the scalar, which is 3, and just differentiate tangent squared t. So this would just be 3 times. Okay, first let's just put differentiate the outer function. So that would just be 2 times tangent t. And now we differentiate tangent in terms of t, so that's just secant squared t. So the final answer would be 6 tangent t secant squared t. And then now we have to find dx dt. So let's write down the equation of x in terms of t. And let's find dx dt. So we have to differentiate this function in terms of t. So in order to find the derivative, we're going to have to differentiate the power in terms of t. So the derivative of tangent t is just secant squared t. So this would just be secant squared t times e to the power of tangent t. Okay. All right. So now we can evaluate our dy dx in terms of t. So this would be dy dt divided by dx dt. So if you want to divide by dx dt, that's also the same as multiplying by the reciprocal of dx dt. So this is what I'm going to do. So as we can see clearly, the secant squares cancel out, and our final expression is 6 tangent t over e to the power of tangent t. So this is our expression for dy dx in terms of t. Okay, so now we're gonna have to find the value of dy dx at these points. But our equation of dy dx is in terms of t, so we're gonna have to find the value of t at either of these points. So we're gonna have to substitute either one of these into either of these equations. So here I'm going to choose e. I'm going to substitute, okay, sub e into, we're going to sub x equals to e into x equals to e to the power of tangent t. So we would have e tangent t equals to e. And by equating powers, e is just e to the power of 1. We can clearly see that tangent t is equal to 1. So now we have a trigonometric equation to solve. Okay, you know what? Since dy dx, everything is expressed in terms of tangent t, we can just write down dy dx as 6 times 1 over e to the power of 1. So we would have 6 over e. So this is the value for dy dx. Hence, we have found our m value, which is y equals to 6 over ex plus c. Okay, so now in order to find the value of c, we're going to substitute both of the x and y coordinates, which is e and 3, into equation 1. So we would have 3 equals to 6 over e times e plus c. So the e's cancel out. So now we have 6 plus e equals 6 plus c equals to 3. So c would just be 3 minus 6, which is minus 3. C is equals to minus 3. Hence, our final answer is y equals to 6 over ex minus 3. So this is our final answer. Let's head on to the next question. Okay, so here we're told that this polynomial will be denoted by fx, where p, q, and a are constants and a is not equal to 0. And the next piece of info, when fx is divided by this, the remainder is minus 22a cubed. And when fx is divided by this, the remainder is minus a cubed. And here we're going to have to find the values of p and q. Okay, so here we're going to have to use the remainder theorem. So the remainder theorem states that like when EX is divided by a linear factor, let's say AX plus B, and remainder R, remainder is R. You're supposed to substitute the linear factor with 0 and find the value of X. So in this case, it's X equals to B, negative B over A. So when you substitute that into PX, you will get the remainder. So this is the remainder theorem. So we're going to use this to solve this question. Okay, so let's solve for X plus 2A equals to 0. So we get X equals to minus 2A. So now let's substitute X equals to minus 2A into Fx. So give us the remainder. Let's substitute, simplify it. 7A squared times minus 2A plus QA cubed equals to minus 22A cubed. Okay, that's a lot to simplify, so let's go ahead. So minus 2A cubed, that's just minus 2 cubed times A cubed, which is minus 8 cubed. And minus 8 cubed times 3, that's minus 24A cubed. Okay, and then minus 2A squared, that is 4A squared. And 4A squared times P times A squared, that is 4P A cubed. Okay, and then 7A squared times minus 2A, that is minus 14A cubed. And we have Q plus Q times A cubed equals to minus 22A cubed. Okay, let's simplify the right-hand side as much as possible. So let's bring the P's and Q's together. And minus 24A cubed minus 14A cubed, we get minus 38A cubed. Okay, let's keep all the P's and Q's on one side and bring the constants to the other side. So we have 4PA cubed plus QA cubed equals to 38A cubed minus 22A cubed. So that's 16A cubed. So as you can see, all the terms on the left and right hand side, the common factor is A cubed, so we can factor that out and cancel it out. So final answer would be 4P plus Q equals to 16. So, okay, let's make Q the subject. So Q would be 16 minus 4P. This is our first equation. Now let's obtain our second equation. So second equation, we're going to use the second piece of info. So let's equate 3x minus a to 0 and solve for x. So x would be a over 3. To substitute a over 3, and we're supposed to get minus a cubed, which is the remainder. So let's do that. 3 times a over 3 cubed plus p times a over 3 squared plus 7a squared times a over 3 plus qa cubed equals to minus a cubed. So simplifying all this, a over 3 whole thing cubed is just a cubed over 27. And 3 times a cubed over 27, that is just 1 over 9 a cubed. And then the following term, p times a squared. Okay, a over 3 squared, that is a squared over 9, and a squared over 9 times pa, that is p over 9 times a cubed. And then for the following term, we just have 7 over 3 times a cubed plus qa cubed equals to minus a cubed. Okay, so like before, let's put the p's and q's on one side. So p over 9a cubed plus qa cubed equals to minus a cubed minus 7 over 3a cubed minus 1 over 9a cubed. So that is minus 31 over 9a cubed. Okay, so to make this simpler, let's just multiply everything by 9 to get rid of the denominator. So this would just be pa cubed plus 9qa cubed equals to minus 31 a cubed. And again, since common factor is a cubed, we can just ignore it and write p equals to 9q, p plus 9q equals to minus 31. So this is our second equation. Okay, and now that we have our two equations, we can substitute. Okay, we're gonna have to use our space wisely here to substitute 1 into 2. So we would get p plus 9 times q, which is 16 minus 4p equals to minus 31. So simplifying this, we would get p plus 9 times 16, that is 144, and 9 times minus 4p, that's minus 36p equals to minus 31. And then p minus 36p, that is minus, my pen's not working, sorry. Okay, minus 35p. And then let's move all the constants to one side. So deducting 144 on both sides, we have minus 31 minus 144. That's 175. And then p would be equals to negative 175 divided by negative 35, which is 5. So this is our first solution. Now let's obtain q. So we have to use our first equation. Q equals to 16 minus 4p. So 16 minus 4 times 5. That's basically 16 minus 20. So that is minus 4. So Q is equal to minus 4. So our final answers are P equals to 5 and Q equals to minus 4. Let's head on to the next question. Okay, so here we're given some Argand diagrams in polar form. So Z1 is this, Z2 is this, and omega is this. Okay, so now supposed to state the values of omega times Z1 and omega times Z2. Give your answers in the polar form, and you were given the domains of the R modulus must be more than 0, and the argument must be between minus pi and pi. Okay, so let's start by obtaining omega times Z1. So that's just 2 times e to the power of half times pi I times 3 times 1 over 4 pi I. So we can just simply multiply the moduluses. So that's 2 times 3, which is 6, and then multiply the exponents. So in order to multiply the exponents, we just have to add the powers, which is basically the argument. So we'll have 6 to the power of half pi I plus 1 4 pi I. So this would just be 6e, 3 over 4 pi I. And now let's check whether both r and theta are in the range. So r is 6, which is more than 0, and theta is 3 over 4 pi, which is between pi and negative pi. So this is our answer for omega times z1. Now let's find omega times z2. Okay, so same process. 3 over 2 times e to the power of 1 over 6 pi I times 2 times e to the power of half pi I. So here 3 over 2 times 2, that's 3. And adding up the arguments or the powers, 1 over 6 pi I plus half pi I, that would be 2 over 3 pi I. So let's check whether both the r and the theta are in the range. So r is equals to 3, which is more than 0, and theta is 2/3 pi, which is between pi and negative pi. So we can conclude this as the answer. So hence, these two are our answers. Let's head on to the next question. Okay, so here on a sketch of an Argand diagram with the origin O, show that the points A, B, C, and D representing the complex numbers Z1, Z2, omega times Z1, and omega times Z2 respectively. Okay, so here we are going to have to sketch them on an Argand diagram. Okay, so let's sketch the axes first. Use the whole space provided. So the horizontal axis is your real axis, and the vertical axis is your imaginary axis. And the center point is your origin. Okay, so let's try to sketch point A first, which is basically Z1. So the modulus of Z1 is 3, and the argument is pi over 4. Pi over 4 is about 45 degrees, so we can write A like around here. Okay, this is a good spot for A. Let's erase all the dotted lines. Okay, oh, all right. So this is our point A. And now let's sketch our point B, Z2. So Z2 modulus is 3 over 2. So it would be closer to the origin. and the argument is pi over 6, which is about 30 degrees. So it would be somewhere around here. As always, it's best if you have a ruler and a protractor to do this. But since I don't, I'm just using freehand. Okay, anyway, let's move on. Okay, so point C represents omega times Z1. So the modulus of omega times Z1 is 6. And the argument is 3 over 4 pi, which is equal to 135 degrees. So that's just 90 degrees plus 45 degrees. So this would be the furthest of the three from the origin. So it would be something like this. Okay, that's a good sketch. Okay, let's erase all this. Okay, so this is C. Okay, and now let's sketch point D, which is omega times Z2. So the modulus of that is 3. So it's the same distance as Z1, which is point A. And the argument is 2/3 pi, which is 120 degrees. So that is 90 plus 30 degrees. So it should be somewhere over here. This is point B. Yeah, so these are our final answers. Let's head on to the next question. Okay, so now we have to state the geometric effects of multiplying Z1 and Z2 by omega. Okay, so from what we can see, by multiplying both of them with omega, the modulus is increased by 2 times because we multiplied the modulus by 2 for each complex number. So we can say the lines became twice as far from the origin. That's the definition of the modulus from the origin. Oh, and then the other effect has to do with the argument, basically the angle which the point makes with the real axis. So as you can see, by multiplying both of these by omega, we increased the arguments by pi and a half radians because we had to add them. So, okay, we can also say that um, underlines the points. Okay, and then the second one should be the points. Um, okay, so all of them, they rotated clockwise. The points rotated clockwise by pi over 2 radians. Yeah, so this is the second effect. So wait, let me check again. Pi over 2. Yep, which is 45 degrees. Pi over 2 is 90 degrees. Yeah, all of them, they, yeah. Okay, so these two are our final answers. Let's head on to the next question. Okay, so here you're gonna have to express this trig equation in this form, where r is more than 0 and alpha is between 0 and pi over 2. And we have to state the exact value of r and give the value of alpha correct to 3 decimal places. Excuse me. Okay, so in order to do this question, let's first expand this expression. So in order to expand it, we're going to have to first expand sine bracket x minus alpha. And we can do that using the addition formula for sine. So this is the formula I'm talking about. Sine A minus B equals to sine A cosine B minus cosine A sine B. So here would be sine x cosine alpha minus cosine x sine alpha. Okay, now we can remove the brackets. So this would be r cosine alpha, sine x minus r sine alpha cosine x. And we can equate that with our original equation in here. Oh, wait, never mind. Okay, let's simplify this original equation as well. So 5 sine bracket x plus 5, x plus pi over 6 minus 4 cosine x. Yeah, let's first expand the sine bracket x plus pi over 6. So again, we have to use the same formula. Sine A plus B equals to sine A cosine B plus cosine A sine B. So in our case, that would be sine x times cosine pi over 6 plus cosine x sine pi over 6 minus 4x or cosine x. Okay, so cosine pi over 6. Okay, that's square root 3 over 2. So square root 3 over 2 times 5 sine x plus sine pi over 6. That's 1/2. So 5 over 2 cosine x minus 4 cosine x. So simplifying all this, we would have 5 over 2 square root 3 sine x plus 5 over 2 minus 4, minus 3 over 2 cosine x. And we are going to equate that with this equation that we have here, r cosine alpha sine x minus r sine alpha cosine x. Okay, so we're first going to have to find r. And to do that, we're going to take the coefficients of the sine x and cosine x's, square them and add them up and find the square root. So this would just be square root 5 over 2 square root 3 squared plus 3 over 2 squared. So let me type it into my calculator. That will give us square root 21. Okay, now we have to find alpha, and in order to do that, we are going to have to equate this, the r's with the coefficients. So as we can see, r sine alpha is 3 over 2, and r cosine alpha is 5 over 2 times square root 3. So here we can just divide r sine alpha by r cosine alpha to give us tangent alpha. And that is equal to 3 over 2 times 2 over 5 square root 3. So, okay, that would be square root 3 over 5. So alpha would just be tangent inverse square root 3 over 5. So when finding out the answer, make sure that your calculator is set to the radian mode because the domain is given in radians. So you get 0.333 to 3 decimal places. Hence our final answer is square root 21 sine bracket x minus alpha, which is 0.333. So this is our final answer for this part. Let's head on to the next part. Okay, and now hence we have to solve this whole equation for this domain. And our answers are supposed to be given to 2 decimal places. Okay, first of all, let's write down this whole equation. 5 sine bracket 2 theta plus pi over 6 minus 4 cosine 2 theta equals to square root 7. So let's try to look for any similarities that we have with our, okay, first of all, since they use the word hence, that means in one way or another, we're gonna have to use our result from the previous part in order to answer this question, or else we won't like get any marks for it. So that's the first thing to note. And first of all, in order to solve this question, we're gonna have to see any similarities with the previous part. So let's do that. Okay, so as you can see, the coefficients are the same, 5 and minus 4. The only difference is instead of x, we have 2 theta. So yeah, we can actually use this result that we obtained here and use it to solve this equation. So square root 21 sine bracket 2 theta minus 0.333 equals to square root 7. Okay, now let's just make sine the subject of this equation. Just to square root 7 over square root 21. So that is just square root 3 over 3. So, okay, so since inside our bracket is 2 theta minus 0.33, we're going to have to change the domain in here. So first of all, we have to multiply by 2. So this would be between 0 and 2 pi. And now we're going to have to subtract 0.33. So this would be between negative 0.33 and 2 pi minus 0.33. And for simplicity's sake, I always like to convert all this to degrees so that I can better visualize. So let's convert this to degrees. So tangent inverse 3 square root 3 over 5 in degrees is 19.11. Yeah, so this would be minus 19.11 minus 2 theta minus 19.11. And 2 pi is 360. So 360 minus 19.11 is 340.89. So this is our range in degrees. Okay, let's draw our unit circle and see which parts of the unit circle our range covers. Okay, our unit circle covers. Okay, so it starts from negative 19.1. So from here, fourth quadrant, all the way to 340. Okay, 340 minus this. Oh, okay. So that is well into here. So it covers from here all the way here. Yeah, so it covers all the four quadrants. Okay. So as we know, first quadrant is A, second is S, third is T, and the fourth is C. So the first quadrant is A, so our sign value is positive. Same for the second one because it's S, while the third and fourth are not positive for sign. And since our sign value is positive, we cannot accept answers from these ranges. So we can only work with the second and first range. Okay. All right, let's find the answer for the first range. So 2 theta minus 0.333. First quadrant would be sine inverse square root 3 over 3, which would give us a very nice answer. Okay, never mind, it doesn't. Let's just find theta. So that's just 2 times sine inverse square root 3 over 3 plus 0.333. So we'll get 1.90 to 3 significant figures. Okay, and for our second answer, it would be in the second quadrant. So in order to find the angle in the second quadrant, we're gonna have to take pi, which is 180 degrees, minus the basic angle, which is your sine inverse square root 3 over 3. So we're talking about this angle. So this is your basic angle alpha. This angle that I'm shaded, we're gonna find this one. So isolating for theta. Wait a minute. Oh, shoot, I'm wrong. It's supposed to be half. Okay, so the answer is 0.474 to 3 significant figures. Sorry for the mistake. Okay, so our second answer would just be half. times pi minus sine inverse square root 3 over 3 plus 0.333. So this would be 1.43, the three significant figures. Okay, so these two are our final answers. Let's check whether they fit the range or not. Okay, so pi is 3.14. So it's between 0 and 3.14, and both of them are in that range, so that's good. So these two are final answers, and if you want to confirm whether your answers are right, just substitute the exact values for theta back into this equation and see if you get square root 7 or not. So let's head on to the next question. Okay, so in this question, we have with respect to the original points A and B have these position vectors respectively. The line L1 passes through A and B. So for the first part, we're going to have to find a vector equation for the line L1. Okay, so first of all, let's sketch the line L1. So this would pass through A and B. And in order to find the vector equation, we have to know the position vector of one of the points on this line and the direction vector. So it's going to be either AB or BA. So let's find AB. So AB is just OB minus OA. So OB is 516 minus OA, which is 204. That's equals to 3, 1, 2. So this is the vector AB. And now we can write down the vector equation, which is R equals to the position vector. In this case, I'm going to choose point A. You can also choose point B. So that is 204 plus lambda times 3, 1, 2. So this would be, so just to be safe, write it down in IJK form. So this would be 2I plus 4K plus lambda bracket 3I plus J plus 2K. So this would be our final answer for this question. Let's head on to the next question. Okay, and now we're told that the line L2 has this equation, and for part B, we have to show that L1 and L2 do not intersect. So basically, we have to show that, okay, so there are two instances when lines don't intersect, either when they're parallel or when they're skew. So skew means they are not parallel and they don't intersect. Okay, so first, let's see if they are parallel. So let's write down the vector equations for both. So it should be 204 plus lambda 312. Okay, now let's expand it. So this would be 3 lambda. So I'm just multiplying lambda with each of these components. So 3 lambda plus 2 and lambda plus 0, which is just lambda, and 2 lambda plus 4. And then for L2, we have 215 plus mu 123 equals to mu plus 2, 2 mu plus 1, and 3 mu plus 5. So these are our expanded versions. Okay, and now, okay, do not intersect. Okay, so as we can clearly see, the direction vectors of L1 and L2 are not scalar products of each other, so they can't be parallel. So they have to be skew. So, to show that they are skew, we're gonna have to equate these two columns that we just found. So let's do that. Okay, so for the first equation, we're gonna choose the middle portion. So this would just be lambda equals to 2 mu plus 1. So this is the first equation. And then the second equation, we're going to choose the the top part. So 3 lambda plus 2 equals to mu plus 2. So we're going to substitute 1 into 2. So that would be 3 times 2 mu plus 1 plus 2 equals to mu plus 2. So this would be 6 mu plus 3 plus 2 equals to mu plus 2. Now let's move everything over to the left-hand side. So this would be 5 mu plus 3 equals to 2. So 5 mu is minus 3, and mu is minus 3 over 5. Okay, and now we're going, oh, we don't have much space. Okay, now we're going to substitute mu is minus 3 over 5 into 1. So this would be lambda equals to 2 times mu, which is minus 3 over 5 plus 1. So that would be minus 6 over 5 plus 1, which is minus 1 over 5. So these are our solutions for mu and lambda. So now we're going to substitute them. So 3 lambda plus 2. That is 3 times minus 1 over 5. 3 times 1 over 5 plus 2. And then lambda is minus 1 over 5. And 2 lambda plus 4. 2 times 1 over 5 minus 1 over 5 plus 4 equals 2. Mu plus 2, that is minus 3 over 5 plus 2. And 2 mu plus 1, which is 2, times minus 3 over 5 plus 1. And 3 mu, which is 3 times minus 3 over 5 plus 5. Okay, and now let's simplify all these. So first one is 7 over 5 minus 1 over 5, 4 minus 2 over 5, which is 18 over 5. And 2 minus 3 over 5, 7 over 5. And 2 times minus 3 over 5 plus 1 minus 1 over 5 and 5 minus 9 over 5, which is 16 over 5. So as you can see, not all the rows are equal to each other, so this is not equal to this, and hence we can say since the solutions are inconsistent, the lines don't intersect. So this is our final answer for this part. Okay, now we're gonna have to find, for part C, we're gonna have to find the acute angle between the directions of L1 and L2. Okay, so in order to do that, we're going to have to use the product rule. So the product rule states that L direction vector of L1 and L2 dotted equals to the modulus of L1 times the modulus of L2 cosine theta. Okay, so direction vector of L1 is 3, 1, 2, and dotted with that of L2, which is 1, 2, 3. Okay, and then the modulus of L1 is just 3 squared plus 1 squared plus 2 square rooted. And for L2, it's 1 squared plus 2 squared plus 3 square rooted times cosine theta. So 3 times 1, that's 3. And 1 times 2, that's 2. And 2 times 3, that's 6. So that's 11. And 3 squared plus 1 squared plus 2 square rooted, that's squared 14. So squared 14 times squared 14, that is 14 cosine theta. So cosine theta would be equal to 11 over 14. Okay, so since cosine theta here is positive, we can assume that theta is an acute angle, since cosine of an acute angle is always positive. So hence, just take the inverse cosine of 11 over 14. So that would be cosine inverse 11 over 14. It can be in any unit you want. In this case, I'm going for degrees. This would be 38.2 degrees to 1 decimal place. All answers in degrees are supposed to be in 1 decimal place. So this is our final answer. Let's head on to the next question. Okay, so here we're told that the constant a is such that this definite integral equals to 4. And now we have to show that a is equal to this expression, where this exponent e denotes e to the power of x. So this just basically means e to the power of this whole thing right here. Okay. So first of all, let's denote this integral in terms of a. Okay, so limits are a1, 6x ln x dx. Okay, so as we can see, the function that we're integrating right here is a product of two functions that we cannot like substitute. So we have to use integration by parts here. So in order to choose our u and dv, we're going to use this rule for u, liet So L stands for log, I stands for inverse, A stands for algebraic, and T stands for trig, and E stands for exponential. So whichever comes first, we're gonna have to make that U. So in this case, we have log and algebraic. So here, we're going to make our ln equals to U. So U would be ln x. So du dx would be 1 over x. And our dv dx would be 6x, and v would just be 6x squared over 2, which is just 3x squared. Okay, so now we're ready to integrate. So this integral, first write down u times v. So u times v is 3x squared ln x, and plug in the upper and lower limit, minus v times du dx. So this would be 3x squared times 1 over x dx. So the x's cancel out, so you just have 3x dx, a and 1. Okay, and now we're going to have to plug in the limits for the first part. So plugging in a, we would have 3a squared ln a. And then plugging in 1, we would have minus 3 times 1, which is 3, ln 1. Ln 1 is just 0. Okay, and then here we have the integral of 3x dx. Okay, so simplifying the left-hand side, this would just be 3a squared ln a minus, you can take out the 3 and just integrate the x. So integrating that, we would get x squared over 2. And don't forget to put in your limits. So this would be 3a squared ln a minus 3 bracket a squared over 2 minus 1 squared over 2, which is just half. And this would be 3a squared ln a minus 3 over 2a squared plus 3 over 2. So this is our final answer in terms of a. Now we're just gonna have to equate it to 4. So let's do that. Okay, we don't have much space. We have to do this quickly. Okay, so equals to 4. So I'm going to move all the constant terms to the left and factor out a squared. So we would have a squared bracket 3 ln a minus 3 over 2 equals to 4 minus 3 over 2. This is 2.5, which is 5 over 2. Okay. And then for this expression, we can move the 3 up to here. So we'll get ln a to the power of 3. So this would be a squared ln a cubed over 3 over minus 3 over 2 equals to 5 over 2. And ln a cubed, we're just going to isolate immediately. So that is 5 over 2a squared plus 3 over 2. Okay, let's see what we have to do. Okay, never mind. Let's just leave this as 3 ln a. Okay. Let's make the denominators the same for both of these. So this is 2a squared, 5 plus 3a. Okay, and then ln a is 1 over 3 divided by 3 on both sides. This would be 5 plus 3a over 2a squared, which is 5 plus 3a over 6a squared. Okay, and take e on both sides. So you only have a equals to e to the, or exponent, bracket this whole thing. And now we're going to split up the fraction to get our result that we have to show. So 3a over 6a squared, that is okay, never mind. Let's just show the result straight away. So this would be 5. Oh, never mind. This is supposed to be 3a squared. Okay, no wonder. Okay, so now this would be 5a squared plus 3 bracket. So this would be our final answer that we have to show. Let's head on to the next part. Okay, now we have to verify by calculation that a lies between 2 and 2.1. So how I like to do this question is to take the result that we proved at the previous part. So this would be a equals to e to the power of 1 6 times 5 over. Okay, so as I was saying, I would like to take the equation from the previous part and, make one side equal to 0. So in this case, I would make the right-hand side equals to 0. So this would be a minus e to the power of 1 over 6 times 5 over a squared plus 3 equals to 0. Hence, this would, okay, now I'm going to substitute a equals to 2. So this would be 2 minus e to the power of 1 over 6 times 5 over 2 squared, so 5 over 4 plus 3. So 2 minus e to the power of minus 1 over 6 plus 5 over 4 plus 3. We would get minus 0.030623 SF. Okay, and then substitute a equals to 2.1. So we get 2.1 minus e to the power of 1 over 6 times 5 over 2.1 squared plus 3. Okay, we got a positive answer, so 0.108 again to 3 SF. So as you can see, from 2 to 2.1, our sign changed from negative to positive. So here we can say, since there is a sign change, a lies between, all of the exact phrasing of the question, 2 and 2 point. So this is our final answer for this part. Don't forget to write verified. Let's head on to the next part. Okay, now we have to use an iterative formula based on the equation in part A to determine a corrected 2 dp, and each iteration should be given to 4 dp. All right, first of all, let's state our iterative formula. So that is very simple. That's just n plus 1 equals to e to the power of 1 over 6 times 5 over an squared plus 3. So first value, we're going to choose a value between 2 and 2.1. So I chose 2.05. And now we're going to set this as our answer value, 2.05, and then type it into the iterative equation, iterative formula on your calculator. So first answer we get 2.0103. Then the next one is 2.0263, and then we got 2.0197. Just keep on pressing the equals button on your calculator until the answer starts to be the same when you round it off to 2 dp. So the next one, we got 2.0224, and then followed by 2.0213, and the next one, okay, we're getting close, 2.0218. The next one is 2.0216, and the next one should be close. We're getting closer and closer. So 2.0216. Yeah, so now it's the exact same. So we can stop here and conclude that our answer is 2.02 to 2 decimal places. So this is our final answer for this question. Let's head on to the next question. Okay, so here we're gonna have to find the quotient and the remainder when this whole polynomial is divided by x squared minus 3. Okay, so first of all, we're gonna have to do long division. So x cubed plus 5x squared minus 2x minus 15 divided by x squared. Even though there's no x term, right, plus 0x minus 3. So let's start. Okay, so first term, it would be x cubed. And in order to make x squared x cubed, we're going to have to multiply by x. So we put x in here. And always remember, whatever term you're multiplying by, always put on top of the term that it is. So in our case, it's an x term, so I put it above the x term in our original equation. Okay, so 0x times x, that's just 0x squared, and minus 3x, that's minus 3x. Okay, so this one is 5x squared minus 2x plus 3x, that's plus x minus 15. Okay, and then to make the coefficient 5x squared, we're going to have to multiply by 5. So doing that, we get 0x minus 3 times 5, which is minus 15. So this would be x plus 0. Yeah, x plus 0. Hence, this would be the remainder, and this is the quotient. So we can write down the quotient is equal to x plus 5, and the remainder is equal to x. So these are our final answers. Let's head on to the next question. Okay. And now we are given this differential equation with x and y, and we're given that y equals to 2 when x equals to 2. So these are our initial conditions. And here we're going to have to solve the differential equation to obtain an expression for y squared in terms of x. So we're going to have to make y squared the subject of our equation. Okay, so let's first write down a differential equation. Okay, let's multiply both sides by 6y. Let's multiply both sides by dx. So now we have these two integrals that we have to solve. So first, let's solve the one on the right-hand side. So in order to solve it, we're going to have to decompose it, express it in terms of partial fractions. So let's write it down. So as you can see, the degree of the numerator is more than the denominator, so we should do long division. And we have already done it in the previous part. So our quotient is x plus 5, so this would just be x plus 5, and then our remainder will be the new numerator, so it's just x over x squared minus 3. So now we just have to simplify this into x over x squared minus 3 in terms of partial fractions. So first, let's factorize x squared minus 3. So that will just be x minus square root 3 and bracket x plus square root 3. And this would be equals to a over x minus square root 3 plus b over x plus square root 3. And the numerators are all constants since the factors are all linear factors. Okay, now let's multiply this equation throughout by the denominator on the left-hand side. So we'll get x equals to a times x plus square root 3 plus b times x minus square root 3. Okay, now we have to make one of the factors equals to 3. So one way we can do that is by substituting x equals to square root 3, and that would make this x minus square root 3 factor be 0. So we would have no term in b, and we will be able to find a. So let's do that. So that would be square root 3 plus square root 3, which is 2 square root 3 times a equals to square root 3. So we can cancel out the square root 3's and we'll get a equals to half. Okay, and now we're going to substitute x equals to minus square root 3. And we did this to make x plus square root 3 0. So then we would have a term only in terms of b. So minus square root 3 minus square root 3, that is minus 2 square root 3b equals to minus square root 3. So we can cancel this out and we would get b equals to half as well. So these are our answers for our constants. So we can conclude x over x squared minus 3 is equal to 1 over 2 bracket x minus square root 3 plus 1 over 2 bracket x plus square root 3. So simplifying, our full expression is x plus 5 plus 1 over 2x minus 2 square root 3 plus 1 over 2x plus 2 square root 3. Okay, so this is our final answer. Now we can start to integrate this. So x plus 5 plus 1 over 2x. Okay, never mind. Let's just keep it unexpanded. Plus 1 over 2 bracket x plus square root 3 dx. We would have integrating x, it would be x squared over 2 and plus 5. Integrating 5, that will be 5x. And integrating 1 over 2x minus 3 square root 3. Well, for that, we're going to have to make it in terms of f prime x over fx. So our fx, okay, first let's take out the half. Then we'll have half times 1 over x minus square root 3. And that is in the form of f prime x over fx because fx is x minus square root 3. So f prime x would just be 1. So hence our answer here is just half ln x minus square root 3. Same for the second one, just be half plus x plus square root 3 plus c. So this is our final answer. And now we're going to have to integrate the y, which is pretty simple to do, which is just 6 times y squared over 2 equals to x squared plus 5x plus half ln x minus square root 3 plus half ln x plus square root 3 plus c. Okay, let's multiply both sides by 2. So we would get 12. We'll get 6y squared equals to x squared plus 10x plus ln bracket x minus square root 3 plus ln bracket x plus square root 3 plus 2c, which we can just write it as b. Okay, and now we can substitute our initial conditions. y equals to 2 and x equals to 2. So 6 times 2 squared, that's 6 times 4, which is 24. And x squared is just 4. And 10 times 2, that's 20. And then plus ln uh, that is 2 minus square root 3 plus 2 plus square root 3 plus b. So simplifying both sides and combining the lns together, since both of them have the same base. So we can multiply the 2 minus square root 3 and 2 plus square root 3. So this would just give us 2 squared, 4, minus square root 3 squared, which is minus 3, plus b. So b would be equals to 24 minus 24 minus ln 1, which is equals to 0. So no constant in the end. Hence, our equation would be 6y squared equals to x squared plus 10x plus, let's combine the lns together. So ln, it would be ln x minus square root 3 times x plus square root 3, which is just ln x squared minus 3. I'm using the difference of squares formula in here. And here our question says we have to express y squared in terms of x. So dividing both sides by 6, we would get our final answer, which is y squared equals to x squared over 6 plus 10 over 6x, which is also 5 over 3x plus 1 over 6 ln bracket x squared minus 3. So this is our final answer for this question. Let's head on to the last question. Okay, so here we're given a diagram with the curve with this equation for this domain, and the curve has a maximum point at M where x is equals to a. Okay, so here we're gonna have to find the exact value of a. Okay, first of all, in order to know what a is, we have to know what our maximum point is. So as you know, our maximum point is basically our is a stationary point. So at that point, dy dx would be equal to 0. So first of all, we have to find our dy dx. So let's do that. First, write down your equation. Okay, and now we are going to find our dy dx. So in order to do that, we're going to have to differentiate this equation. So we're going to differentiate cosine x times sine 2x to the power of half. And since this function is a product of two functions, we're going to have to use our product rule for this. So I'm going to keep the cosine x first and differentiate the sine 2x. So we're going to have to use the chain rule for this. So first we differentiate the outer function, which is just a half times sine 2x to the power of negative half, which is just sine 1 over square root sine 2x. And then now we're going to differentiate sine 2x, which is just 2 cosine 2x. So this would cancel each other out. And now we're going to keep square root sine 2x. and differentiate cosine x, which is just minus sine x. So simplifying everything we got, this would basically just be cosine 2x times cosine x over square root sine 2x minus sine x square root sine 2x. Okay, now we have to equate our dy dx to 0. Okay, in order to do that, let's first get rid of the denominator. So we have to multiply both sides by square root sine 2x. So let's do that. Cosine 2x times cosine x minus sine x times sine 2x squared. So that would just be sine x times sine 2x equals to 0. Okay, and now let's express cosine 2x using our formula sheet. So cosine 2a equals to cosine square a minus sine square a, and sine 2a equals to 2 sine a cosine a. So let's do that. It's cosine square x minus sine square x and 2 sine x times sine x, so sine square x cosine x equals to 0. So we would have cosine cubed minus cosine x sine square x is 2 cosine x sine squared x equals to 0. Okay, so now we're gonna have to change the sine squared x to cosine squared x using this identity. Sine squared theta equals to 1 minus cosine squared theta. So let's do that. So let's expand everything. To cosine cubed x. Okay, so for the cosine cube x terms, as you can see, they're going. Okay, so the cosine cube terms, 1 plus 1 plus 2, that's 4 cosine cubed x. And for the cosine x terms, we have minus cosine x minus 2 cosine x, which is minus 3 cosine x equals to 0. And now we're going to factor out the cosine x to get cosine x times 4 cosine square x minus 3 equals to 0. And then we got cosine x equals to 0. And x could only be equals to pi over 2 for our domain. But as we can see from the diagram, m is not at x equals to pi over 2. So that is definitely not the case. So we're going to have to reject this answer. So let's look at our second solution. For cosine x squared minus 3 equals to 0, cosine squared would just be 3 over 4. So cosine x would be plus or minus square root 3 over 2. So let's look at our domain. So our domain is between 0 and pi over 2. And that's covering only the first quadrant. And the first quadrant, all the ratios are positive, so cosine is positive. So we're going to have to reject it. So x will just be cosine inverse square root square root 3 over 2, which is just, don't forget to set it to radians. It's just pi over 6. So this is our final answer. Okay, wait, no. No, so hence A is equals to pi over 6. This is our final answer. Let's head on to the next question. Okay, so here is saying the region enclosed between the x-axis and the curve is rotated through 2 pi radians about the x-axis, and we have to find the exact volume of the solid generated. Okay, so to find this, we're gonna have to use the formula pi times y squared dx to find the volume, and then these would be our limits b and a. So first, let's see what our limits are. So the area they're talking about is this area. So we can form our integral easily. First, we just have to find our y squared. So this would be 2 cosine x. Oh, what the hell? Okay, never mind. Cosine x times sine 2x squared. So this is just cosine squared times sine 2 squared. Okay, and then to make the integration simpler, we're gonna use the identity double angle formula for sine 2x, 2 sine x for sine x. So this would just be 2 sine 2 sine x cosine cube x. So this is our value for y squared. Now we can form our integral. So our limits are pi over 2 and 0, and will just be pi times y squared, which is just 2 times sine x cosine cubed x dx. Okay, let's simplify the integral. Let's take out the constants 2 pi. Now we have pi over 2 and 0 cosine cubed x sine x dx. Okay, so here we can use a u substitution. So we're going to substitute u equals to cosine x, and du dx will just be minus sine x. So multiplying dx on both sides, we get du equals to minus sine x dx, and sine x dx will be equal to minus du. So and don't forget to adjust the limits for the new substitution. So the upper limit would be cosine pi over 2, which is 0. Lower limit would be cosine 0, which is 1. And even if the upper limit is less than the lower limit, don't change the order of the limits. Hence, our final integral would be 2 pi integral of 0, 1 u cubed times minus du. Let's remove the negative sign out of the integral, so we'd have minus 2 pi integral of 0, 1 cubed du. So integrating u cubed with respect to u, you would get u to the power of 4 over 4, and the limits are 0 and 1. So this would be minus 2 pi times 0 over 4 over 4, that's 0, minus 1 to the power of 4 over 4, that's 1 over 4. So putting it into your calculator, you would get half pi units cubed. So this is our final answer for this question. And if you want to check whether your answer is correct, you can do so by writing this exact integral into your calculator and seeing whether you get this exact answer. Same for the question in 11 part A. So we have come to the end of this paper. I hope you found this video helpful. If you have any questions or doubts, feel free to put them down in the comments below, as well as what other future video ideas and papers you would like me to do next. And I will see you next time. Okay, thank you.